So once you start putting together all the complexities of aging, then you start seeing that orthopaedics is really important because it will be the cause of disability, retiring early, not returning to work, like you're saying, with back pain. So if you can convince someone of that, then they're more likely to fund you. So it's really convincing people of the rationale as to why something's important. We don't really have to change our research topic just because of what the government's funding, because there's enough breadth in there. But you do have to convince them why it's important to the government. So every time you propose a research question, it has to be, but why should I care about this? Why is it important? Which in healthcare is fairly easy to do, but with some of the more fundamental questions about the bone cells, if we go back to the early part we were talking about, there's some very interesting, very fundamental questions about how bone works, which is more difficult to convince people of their importance. Yeah. So you always have to tailor it to, well, how could this eventually develop a new medicine or a new therapy or something? And that can be a bit frustrating sometimes when you just think, but I just want to know because it's just interesting.
Yeah, exactly.
Yeah.
How do you go about measuring in terms of, you need to explain, of course, the clinical application of your research, but then a lot of it is just discovery and just taking one step forward. So then when you're pitching that, whilst you may have to focus on this is how it could be used eventually, but we're not at the stage that, let's say, some of these tissue engineering products would actually be used in a human or in a fracture or in chronic back pain. Is that a challenge then, explaining to people when you may have to talk about how it would actually be used, but then you're still not there yet? You still need to
exactly. So it really is a challenge, and especially the fact that, of course, you don't yet know until you've done the experiment if it's going to work. Yeah. So it's the risk factor. So whenever you write a proposal and you ask for funding, you have to explain what you think the risk is. And again, it will kind of depend on that funder. So some funders don't mind funding high-risk research, and some funders are more conservative on that. For example, it would depend if you're applying to the government or to a medical charity. So medical charity naturally and logically wouldn't want to fund something too high risk because people have donated money to cure a disease. And so they don't want to fund something that's only got a very small chance of curing that disease. The government might be a bit more happy to take that risk because they understand more the need for blue skies research in your field. But that would depend on the scheme. Is it a blue skies research scheme or is it a more applied scheme? So when you're asking for money, you really have to look at what kind of funding is that and what did they ask for within their blurb when they released that offer, because they'll always release the description of the grant, and they'll say this grant is for, and they might say for blue sky research, for basic science, for medical applications, for applications in civil engineering, whatever. So you have to really read it and think, does what I want to do fit what they're asking here? And if not, you might rather go to another scheme than try too hard to fit a square peg in a round hole. So there's no point trying to force something that really doesn't fit the remit. Better look for another remit. So that's kind of how we do it. We look at what they're asking for, how applied is it, and if I do something blue skies, what am I better asking somewhere else? Or the other thing is to explain that step by step how it could lead to that thing. So you might say, well, it is risky, but if it works, it could provide this huge benefit and could prevent low back pain for these thousands of people. So, and if it's a big potential gain with high risk, sometimes that will be funded because that's called high risk, high gain research, where, okay, it's risky, but if it does cure this thing's so important, it could still be worth taking the risk.
Are there targets you have to meet? Because, yes, you propose this project and you complete that in a certain amount of time, but targets in the sense that when would this eventually lead to a clinical application, or when will something, I guess, be achieved or something be discovered? Do you have those pressures that puts on you? Because tissue engineering is, there's still a lot more that needs to be understood to then, create something of clinical relevance. How are targets placed on you?
Not really, to be honest. Okay. I mean, if so, they are quite minor in terms of their targets, in terms of the results that should have been generated by then. Not in terms of like a product or a clinical solution, unless at this stage, so at the sort of stage that my work would be. So there are other types of grants based on clinical trials and so on, and those might have dates attached to them. And you might have to have got 100 patients enrolled by date X and have the results by date Y, depending on the scheme and how you've written it. And then, because anyway, any clinical trial is extremely expensive and you don't want patients enrolled for longer than necessary and so on. So those kind of projects would have very specific dates. But by the time you get to a clinical trial, you've done all that scientific development to have something that's good enough to go to a human anyway.
Exactly.
When it comes to the step before that, no one would really expect you to put those kind of targets and dates on it. It would be dates in terms of these experiments will have been done by this date, but the results, I don't know. They may show something interesting, they may not, or they may just show we need to do more work. And that is fine, that is expected, because these grants are usually reviewed by other scientists that are in a similar field. So they would understand the process and they would know that you can't commit to saying this will be ready by this day. It's not really expected, as you say, especially in a field like tissue engineering, which is still very nascent in terms of the applications are long term. It's not something that's being readily used in the clinic yet.